Welcome to this new tutorial. In the previous tutorials we learned how to create the lasers, the neural network and all the algorithms. And now we'll be creating the car movement. In the car movement we'll learn how to move each car, and as you can see in the screen, this is what we did in the previous video, all the lasers and that stuff. So now we'll need to create a new C# script, and we'll call it a car. Double click on it and go to Visual Studio. And here we have the same structure as before. We'll need to create some method, some variables. Firstly the DNA, because each car will have a DNA. Also we have the neural network, because also each car will have its own neural network that will have the weights that are assigned to the DNA. The DNA weight is the weights of the neural network. And also we'll need to create a vector 3 for the initial position, that we'll call it initial point, and a private float called distance, that will be the distance from the initial point to the current point. So now we'll create a boolean value, because if we want to know if the car is initialized or not, and we won't put anything in the start method. We will create a method called initialized, and we will have two initialized methods. One will be for the first generation, and the other for the next generations. One will have the random values and the other not. The first will have the random values. Constructor will create the neural network and also the DNA that will have the weights, the random weights of the neural network. As you can see here in the neural network, we create the random weights. Here we have generate random value, so we will have completely random behavior of the car. And as I said, this will be assigned to the DNA. Then the initial points will be updated with the current position of the car. And finally, we'll need to put initialize to true. We'll need to create a second method that will have one parameter that will be the DNA. This network will have learned with the genetic algorithm. So when we create the neural network, the neural network will pass the DNA, because we want the weights to be the DNA. And we will also put the DNA of the neural network as the DNA that we pass to the constructor. Then we'll need to put also the initialize point, the same as the other constructor, and initialize to true. Then in the update method, we'll do a condition if the car is already initialized. Well, this is the important part, the most important part that we learned in the previous videos, in the learning videos. We'll get the components, the component lasers that we created in the last video, and we'll get the distances that will be the inputs, as I said. These inputs will be stored in an array of floats, and as I said, we'll get the inputs of the distances that will be the laser component that we created. Also, we'll need to do the feed forward of the neural network to update with the inputs, and also we have the weights when we initialize the car. We'll do the feed forward with the inputs parameter, and then we'll need to get the list of outputs that our neural network has predicted. So we'll put the neural network dot get outputs, and we'll finally make the most important part. Now we'll need to get the component, but we'll do this later because we haven't created yet the class that is the movement of the car. So we'll need to put also the distance that the car has traveled, that is vector 3 dot distance, and the transform position, and the other, that is the initial point. Then we'll create a method called onTriggerEnter that we will create this in the next tutorials. And this is when a car has collided, it will create a method. Now we need to create the new script for the car movement. I will call it car move and reload the Visual Studio. Then in the car, as I said, we need to do the get component dot car movement, and you need to type this that will create a new method that will be update movement of the car, and we need to pass the outputs, and we'll be creating soon. So this class is completed. We need also here in the TriggerEnter to fill with the camera that we'll be doing in the next tutorials. Now go to the car movement class. Now you are in the car movement, and here you have the method start and update. We'll need to create a float that will be the speed in rotation speed, because we will have two outputs from the neural network that will be the acceleration and the rotation. Then you will need to also create a new float that will be the speed and the linear speed, that is the speed that the car is having in the direction of the rotation. And finally, we'll need to create a vset that will be another speed and acceleration, and one float that will be the increase of the acceleration, that this is the value that our neural network will give us. You can use only the rotation of the neural network or also the acceleration. Now you will need to create a boolean that will be active acceleration to have a setting that can adjust if we are using acceleration or not. Now we need to put the speed in the set to a speed linear, because this speed will change if active acceleration is true, and we will need to get the delta time, that is the time in every frame that we call. Now we'll need to increase the position. We'll need to get the vector depending on the rotation of the car. It will be the vector rotated, and we'll need to multiply this vector by the speed. So it will depend, the speed vector will depend on the rotation. So depending on the rotation, the car will be moving towards that vector. And we'll need to apply the acceleration movement formula, that is that. And now we'll need to rotate the car with the rotation in the y-axis. That is the axis that we are rotating. Now we'll need to create some methods that will return us some values. The first will be the rotation, but we'll hit it because we'll be don't doing it for now. Instead, we'll be using a method for getting the acceleration, the current acceleration, and this will return us the acceleration. And then finally, a method for updating the movement. It will get us the outputs of the neural network. So when we get execute the feed forward of the neural network, we'll get the values and we'll pass it to update the movement. And it will be a list of floats. And here we'll need to update the movement as we do in the last method in the previous class, the car class. And here we'll need to, depending on the values of the neural network, change these values for the acceleration and the rotation. And we'll need to do a tricky in a tricky way, because this is giving us values from 0 to 1, and we want also negative values, because we want the car to move left or right, and it depends that in if it's negative or positive, and also with acceleration. So this will get a value from 0 to 2, because the outputs, remember, are from 0 to 1, because of the fact that we are using the sigmoid function. So this method is doing that value between 0 to 2, and if it's greater than 1, it will be positive, and if less than 1, it will be negative. And when this will be done with the value of 0 between 0 and 2, and we will minus 1, and that will give us a value between minus 1 and 1. And we will also increase by a constant that will be increased acceleration. This constant will be adjusted in the Unity codes for increasing the sensibility of the car or decreasing it. And if the output multiplied by 2 is less than 1, we'll do another thing. We'll need to put minus the outputs in position 0, in position 1. And here we'll need to create another condition that is for the outputs, because I have done something wrong. Um, Firstly, we are mixing acceleration and the other. So in position 0, as you see, the acceleration is output in position 1, and the output in position 2 is the rotation, and we will do the same as before. For example, here, if the output in position 0 multiplied by 2 is, for example, 1.5, it will execute the first condition, and in the first condition, it will give us a positive value. So it will be a value between uh, a, a value 2 between 0 and 1, the rotation also. And here we'll do the same as with the acceleration. But we'll need to update the speed of the rotation by the delta time. And also the speed rotation is like a constant that will increase the sensibility of the rotation. This is the same as the acceleration. You can see here that as I explained, if the value is between 0 and 2, the value is between 0 and 2, if it's greater than 1, it will give us there a positive value. That will be a value between 0 and 0.5. And there it will be a negative value between that values. So now, if we execute, we won't see any movement. This is because we need to increase the constants. Here you can add the component. Also you need to add it, the car component and the car movement. Okay, but now the speed limit is too low, so we need to increase it. Because we have two constants, as I said, the acceleration, the speed of the rotation and the speed length and the increased acceleration. So now we'll change it, the rotation, the speed rotation, and the speed linear. As you can see here, the car now is movement. So we have done it, and in the next tutorials we will be making the rest of the things. We need to create the collide and also the car controller and the camera. And we are almost finishing. I know that is a lot of code. Sorry for making a voice that is not depending on the video, because I forgot to record the audio. You also need to change one thing that is an error I forgot, that is this to have in position 1. Save and remember to do it.